Problem 24. Suppose that a, b, c, and d are positive integers satisfying all of the following relations. Pause for a few seconds to read the conditions. The question is, what is the greatest common divisor of a, p, c, and d? The solution is, notice that because the prime decomposition of a, b, c, d consists only 2, 3, and 5 as prime factors, each of them should contain only 2, 3, and 5 as prime factors. Now let a equals 2 to the power of a 1 times 3 to the power of a 2 times 5 to the power of a 3, b equals 2 to the power of b 1 times 3 to the power of b 2 times 5 to the power of b 3, and c equals 2 to the power of c 1 times 3 to the power of c 2 times 5 to the power of c 3. We will now find each exponents using the condition given. Comparing the exponents of 2, we have that the maximum of a1 and b1, the maximum of a1 and c1, and the maximum of a1 and d1 are all 3. This gives that a1 is 3. Now, since the maximum of b1 and d1, and the maximum of c1 and d1 is 2, d1 is equal to 2. We have a1 plus b1 plus c1 plus d1 equals 6, so b1 plus c1 is 1. Therefore, one of them should be 1, and the other should be 0. The minimum of a1, b1, c1, and d1 is 0, so 2 doesn't divide the greatest common divisor of a, p, c, and d. Next, comparing the exponents of 3, we have that the maximum of a2 and d2, the maximum of b2 and d2, and the maximum of c2 and d2 are all 3. This gives that d2 is 3. Now, since the maximum of a2 and c2, and the maximum of b2 and c2 is 3, c2 is equal to 3. We have a2 plus b2 plus c2 plus d2 equals 9, so a2 plus b2 is 1. We then have that the maximum of a2 and b2 is 2. Therefore, one of them should be 2, and the other should be 1. The minimum of a2, b2, c2, and d2 is 1, so 3 is the greatest power of 3 dividing the greatest common divisor of a, p, c, and d. Finally, comparing the exponents of 5, we have that the maximum of a3 and b3, the maximum of a3 and c3, and the maximum of a3 and d3 are all 3. This gives that a3 is 3. Now, since the maximum of b3 and c3, and the maximum of b3 and d3 is 2, b3 is equal to 2. We have a3 plus b3 plus c3 plus d3 equals 6, so we are left with c3 plus d3 is 2. Because the maximum of c3 and d3 is 2, one of them should be 2, and the other should be 0. The minimum of a3, b3, c3, and d3 is 0, so 5 doesn't divide the greatest common divisor of a, p, c, and d. Therefore, the answer is 2 to the power of 0 times 3 to the power of 1 times 5 to the power of 0, which is 3, so the answer is A.